Okay, for this question, right, Hayden, if you take a look, they mention about the perpendicular bisector of the chord BD. So first of all, when we first read the question, you need to realize that this is the chord. Okay, the question will tell you the chord, and then from the center, it is bisecting the chord. That means it actually cut the chord into half. So that is the meaning of bisecting, bisector. And it will cut into half in a perpendicular manner. So that exactly fit the property that we learned in property 1 and property 2. So because of this, the BD here will be divided into two parts. So it will be divided into like 7.5 here, and then it will be divided into 7.5 here. Okay, and we are also given a tiny part here. So in case you're wondering, is there a use for this tiny part, right? Yes. Okay, so later on we got a use for this tiny part. Okay, then the first part, right, is usually the critical part. Most students will be stuck at the radius. So if you still recall the video that you watched for property 1 and 2, radius is always everywhere. So radius is always everywhere. Anything from the center, it will have become a radius. So anything from the center will have become the radius. So all these are the radius, okay, including this whole thing here, including OC. So if you take a look, right, OC should be the radius as well. But then, right, there's a tiny part that is even out of OC. There is a little part MC here. So MC is given to be 3 centimeter. So from here, we can think about what is OM. Okay, so the whole of OC is actually a radius, but there's a tiny part MC, which is part of the radius. So from here, we got a R minus 3 for this part. Okay, so why do I aim the R minus 3? Because I'm trying to do a Pythagoras theorem. So eventually, in order to find the radius, I am trying to do a Pythagoras theorem. Okay, so I'm targeting OM, which I gotten from here, which is a R minus 3. And I know that this is a radius. Anywhere from the center is the radius. So I gotten a radius. I gotten a 90 degree. The 90 degree also come from the property. And then I also gotten a 7.5. Okay, where do I get the 7.5? Because the property also tell us that it will cut the chord into half. So if I form a Pythagoras theorem from here, I should be able to solve for R. Okay, so the plan is to solve for R using a Pythagoras theorem. So the Pythagoras theorem will be something like this, which I will need you to be trying. It will not be something complex. You will end up with a quadratic. So maybe your answer may not be so nice, but it will still be confined within the idea of a quadratic. Okay, so later on, you need to see whether you can execute this and get the radius. So if the radius is not going to be nice, you present it as 3SF, but subsequent part, right, you do not use a 3SF radius. You use the more decimal place radius. Okay, so because of the 90 degree that is happening in the property, it allowed me to use a Pythagoras. And then because radius is everywhere, so I managed to form a triangle. And then because the chord is being cut into half, that's why I managed to get something like this. Okay, so that is the radius part that you will need to be trying. And then I will just brief on second part first. Later on, you can try to execute the full thing out. But you look at it as a bigger picture, because this question can come in different shape, but you must be able to detect the radius. Okay, so the next one, right, is actually what you learn in arc length and sector. So in arc length and sector, we learn something called segment. So this is the segment that we are interested in. So this segment comes from a pizza subtracting a triangle. So segment will come from a sector minus a triangle. Okay, so if you recall what is the formula for sector. So if I would like an area, I will require an angle here. So I will require an angle. So this angle, again, right, I'm going to find it in this right angle triangle. Okay, so this can be found in the right angle triangle, depending on whether you want to use sine, cosine, or tangent, because you will have all the length already. Okay, so you can find, but then, right, the angle that we want will be 2K. This one can only help me find half of it. So it's only here, this part. Okay, so I will need the angle BOC so that I can execute the sector formula. So the sector formula will be BOC over 360 times pi r squared. So the R has to come from the first part. But you cannot be using the 3SF radius. You use the more accurate one. And then for the triangle, it will be the half AB sine C that you learn in your trigo. But the angle will be BOC. And then the AB will be the radius. So this question marry property 1 and 2 and the sector idea that you learn.